Hello viewers, welcome you all to my video lecture on LCD and interfacing it to 8051. In this session, we get first introduced to LCD liquid crystal display, its definition, its applications and the importance of the topic, why somebody should know, understand or learn this topic. And then we go with the LCD signals. LCD signals like LCD pinout diagram and its signal description. And then interfacing of LCD to microcontroller 8051. Here we will discuss about the possible ports which can be taken for interfacing and also other control signals. And then writing an assembly language program to display the data on LCD. So for this we need to know the steps or the logic behind the program. So going ahead, so first LCD. LCD stands for liquid crystal display. An LCD is electronically modulated optical device shaped into a thin flat panel made up of number of color or monochrome pixels filled with liquid crystals. Or otherwise we can also say it as in one line, LCD screen is an output display device widely used in embedded systems. An image is also included in this slide so that you can understand it. Then we will try to understand the reason why the LCDs are replacing the LEDs. So one of the very important reason is it requires very low power. So as it requires very low power, it can be used in the battery powered electronic devices. Most of your embedded systems are battery powered, so you can use them in the battery powered electronic devices. And then because of the low prices of LCDs. If you go with the LEDs can give only the notification. But when you go with the LCDs, it has the ability to display characters, numbers and graphics. And the ease of programming for characters and graphics. So these are the few reasons behind why the LCDs are replacing the LEDs. And then knowing about the types of LCDs. So usually we have got two types of LCDs. Alphanumerical LCDs which are used for displaying the alphabets and numerical values, and graphical or customized LCDs which are used for displaying the pictures. Some of the formats available in LCDs are, first one 16 by 1. So we can display 16 characters in one row as it is shown in the diagram. One row 16 characters. 16 by 2, it is a two line display. Each line 16 characters can be displayed. And then 20 by 4. So it is a 4 line display. So 4 line display. So each line can be used to display 20 characters. So these are the various formats available in the alphanumerical LCDs. And then going with the basics. So studying the LCD signals. As you can see in the picture, it is a 16 by 2 LCD. It is a 16 by 2 LCD. So first what is required is the data lines D0 to D7. So whenever microcontroller wants to write anything in writing is like whenever it wants to display it or give a command to the LCD or to read the status of the LCD, it is done using the D0 to D7 lines. And then we have few control signals. First one is RS register select. LCD usually has two internal registers. One is the command register, the other one is data register. To select the either command register or the data register, we use the register select pin. And then we have read/write. So whenever it is a read operation, it has to be equal to 1, and whenever it is a write operation, it has to be equal to 0. Why it has to be equal to 0? Because there is a bar on the right. And then enable. Enable is a maybe during the read or during the write operation, enable has to be equal to 1. It is a signal going from high to low. Means from 1, first a 1 has to be given and then a 0 has to be given. Next, going with the potentiometer. Usually we use the 10 kilo ohms potentiometer. So potentiometer has 3 terminals. The 2 ends are given for the VCC and VSS, and the variable is given to the VEE. Variable terminal is given to VEE. To change the brightness, we use this 10 kilo ohms variable potentiometer. So by varying the resistance value, we can vary the brightness of the LCD. So going with the LCD signals. So LCD, as already I have told you, it has got 8 data lines D0 to D7. A register select RS, then read oblique write bar. There is a bar on the right, read oblique write bar. Enable, which is from high to low, and then VCC plus 5 volts. VE is the variable terminal given to the potentiometer to vary the brightness of the LCD, and then VSS is given to the ground. So going in depth, in detail. So RS, register select. LCD has 2 internal registers as already mentioned. When I give RS is equal to 0, it selects the command register. Whenever I give RS is equal to 1, it selects the data register. So whenever the microcontroller is giving a command to the LCD controller, then RS should be equal to 0. Whenever it is writing the data which has to be displayed on the LCD panel, then RS is equal to 1. Next, read oblique write bar. Read oblique write bar. So as there is a bar on the right, so whenever it is equal to 0, writes data to LCD, and whenever it is equal to 1, reads data from the LCD. Enable, so used by the LCD to latch the information on data bus pins for read operation as well as the write operation. So the required signal is a high pulse to be sent on the enable pin. And then going with the LCD interfacing. So if you see the diagram, so first one D0 to D7 lines. D0 to D7 lines of LCD display. Here we are selecting the port 2. We all know that 8051 has got 4 ports. In that I am selecting the port 2. It is a 8-bit bidirectional bit addressable port which I am using to connect it to the D0 to D7. Whenever the controller has the data or the command word to be sent to the LCD display, then we use the 8 lines. The other control signals we have is the register select RS P1.0. I am using P1.0 here, and for read oblique write bar I am using P1.1, and for the enable which is used for latching the information I am using the P1.2. Because from P1.3 to 1.7 here in this program we are not using it, they are all connected to the ground. And coming to the potentiometer or the brightness control, we connect the 2 ends of your port, to the one to the VCC, the other one to the ground, and the variable is connected to the VEE terminal. So this is a very important diagram. I repeat it again. So I am using the port 2 for the data lines, and then For the control signals, I am using the lines from the port 1 P1.2 for the enable, P1.1 for the read oblique write bar, P1.0 for the register select, and all other from P1.3 to P1.7. As I am not using here, I am grounding them. Then is the initialization commands. So there are like few initialization commands. These are the usually when we try to display anything on the LCD, first we send the command and then we send the data. So first is your 38H. Sending a 38H, it sets up the 2-line display, or else I can also say it as use it to select LCD of 2 rows which are of 5 by 7 matrix. Each character is like a dot matrix, it is 5 by 7 matrix display. 0F. 0F is for the display on or cursor on for the cursor blinking. 01 to clear the display. So maybe there is some garbage value already present. So in order to clear it off, we give the 01 command. And then 06, if you want to, usually we write from the left to right. So we give the 06H. And to start from the line 1, position 1, we give the 80. Sorry, here it is 80. 80H. So these are the various initialization commands to be given to the LCD controller, so that after we give the commands, then we can send the data word which can be displayed. So what we'll try to learn the steps to give the command and steps to give the data. First, steps to give the command. Place the command word on the port. So which port? On the port 2, because here from the diagram it may not be always, because here in this I have selected the port 2, place the command word on the port 2, and then I need to select the command register. So make RS is equal to 0, and it is a write operation because I am giving a command, it is a write operation. So read oblique write bar is equal to 0. Then enable pin, as I told you, it is a high to low pulse. So first send a 1 and then a 0. Usually the LCD may require some 10 milliseconds, 15 milliseconds depending upon the specifications of it, but here I am assuming the delay is 10 milliseconds of delay is required. So repeating again, how to send a command to the LCD controller. Place the command word. What are the command words? 38, 0F, 01, 06, 80. So these are the command words. Place the command word on the port 2. After placing the command word, then select the command register. After selecting the command register, make the read oblique write bar is equal to 0. And then enable. Send a 1 first and then a 0. And here we are assuming the delay required is 10 milliseconds. So call a delay program for 10 milliseconds. Now steps to write the data. So this is like the data is what to be displayed. So this is like ASCII value. Same way, place the data on the port, here port 2, then make RS is equal to 1 because I am selecting the data register, RS is equal to 1, and make read oblique write bar is equal to 0 because it is also again a write operation, and then make the enable high to low, enable pin high to low, it is a latch, and then call for the delay and let the delay may be approximately 10 milliseconds. So before writing the program now, we have done with the interfacing diagram and also the commands to be given to the LCD display controller. Then we have seen the steps to write the command word and also the data word. into the command register and the data registers respectively. So here I am writing a program. Write a program to display hello MREC. Hello MREC. So usually the space also it is also a character, so it also should be given with a one memory location. See here, I am starting with the 0500 location. So there in colons H, in colons E, in colons L, so on. So here the ASCII value will be taken by the processor or the controller. So 500H, 501E, 502, 503, 4, 5, 6, 7, 8, 9. So 0 to 9 locations. So 500, 501, 502, 503, 4, 5, 6, 7, 8, 9. Hello MREC. So this is like a lookup table. So first we go with the lookup table, and where I have started storing my ASCII values from the 500 memory location, and I am initializing the DPTR to the 500 memory location. Now starting with the program. So move DPTR hash 0500H means what? You are initializing the DPTR register and then send the initialization commands. So how do you send the initialization commands? Usually we use the accumulator register. So move A comma hash 38H. So 38H, what is the 38H does for us? 38H is used to select the LCD of 2 rows, and then we will send the 0F. Move A comma 0F. It is used for display on cursor or on the cursor blinking, and call the CMD. CMD means what? It is an subroutine written for sending the command word. A call is absolute call CMD, calling the CMD subroutine. Similarly, we send all the commands 01, 06, 80. So here if you observe, each time I am placing the command into the accumulator register, and then I am calling the subroutine related to it. So let's understand the subroutine here. So CMD move P2 comma A. So what I am doing here? CMD P2 comma, this is for the writing the command word. So A has a 38. What is 38? It is a command word. Now I am placing it in the P2 on the port 2, and then clearing P1.0. What is this P1.0? Register select. So make the register select 0 because you want to select the command register, and then make the read oblique write bar is equal to 0. So clear P1.1. Then make the write enable 1 and then 0. So make it a 1 means set B, make it a 0, a high and a 0. A high, a 1 has to be sent, low, a 0 has to be sent. This is what is your enable. Then call the delay. So let the delay program is for 10 milliseconds. I have not included the delay program here. So you can write a delay program and you can call it in this subroutine. A call delay, return to the main program. So this is how we send the command word to the LCD. So place the command word into the accumulator register. From the accumulator register it is sent on to the port, and then clear P1.0, nothing but making R is equal to 0, making read oblique write equal to 0, and then latching the information by making enable it equal to 1 and then 0, calling the delay. So this is about the initialization, and then till here it is initialization. Move R7 comma 0A. So what is this 0A? If you see the program, how many locations did I use for storing the text whatever I want to display? 1, 2, 3, 4, 5, 6, 7, 8, 9, A. It is 0 to 9 means 10 locations I have used. 10 is nothing but A. In hexadecimal, 10 is equal to A. So move R7 is equal to move R7 0A. It depends upon the text what you want to display on the LCD. It may vary from like 10 to any characters. You need to just count the number of characters and place it in the R7. Move R0 is 0, 0. Here I am going with the indexed addressing mode. So here what is the next part? First we have initialized, and then in the initialization program we have called the command program, and then now sending the data. Each time I have to get the data from the lookup table and call the data subroutine. Now see here, move R0 is, it is starting, move R0 is equal to 0, 0. Next move A comma R0. So now what does A will have? A will have the 0, 0. Move C, A comma at the rate A plus DPTR. A has the 0, DPTR has the 500. So 0 plus 500, 500 memory location. So it should point to the 500 memory location, and the data which is present in the 500 memory location will come into the A. Means what? The ASCII value of the hello MREC was the text whatever we have chosen. So now the ASCII value of the H will come into the accumulator register. Then A call data, absolute call data. Data is the subroutine which already we have written. Then increment R0. Why we are incrementing? Then again we have to go for 501, 502, 503, so on. And we are decrementing the R7 register, because R7 register is holding the count of the characters to be displayed. So let's go into the details of the data subroutine. So in the data subroutine, so as already you know that the steps to give the data. So first place the data onto the port 2. Then set P1.0. Why we are setting P1.0? Because it is an register select. 1.0 is a register select, and register select has to be equal to 1 when I am selecting the data register. So set B P1.0. Then clear P1.1. So whether it is, what is here P1.1? P1.1 is the read oblique write. So whether it is a command or the data is flowing from the microcontroller to the LCD display. So what happens? A clear, it has to be made to 0 because it is a write command. And then set B P1.0 and clear B. So these two are again enable. So set B means 1, I am sending a 1, and clear 1.2 a 0. So I am latching the information. Then calling the delay program. Delay program again is of the 10 milliseconds, or you can write any delay depending upon the specification of the LCD which you are using in your hardware circuitry. Then return to the main program. See here, once you return to the main program, you are decrementing the R7 and doing the again same. So each time R7 I am decrementing. So I am decrementing the R7, incrementing the R0. So what happens? So once R0 is incremented, so 500, 501, 502, 3, 4, 5, 6, so on until R7 becomes 0. Once R7 becomes 0, it is going to come out of the loop. Here I am initializing the string. Where did I store the string? 500 memory location. I have stored the string at the 500 memory location. String org0500h. And db is the assembler directive, define byte. What was the text which I want to display? Hello MREC. So string org 500. It is not 400, it is 500. And define byte hello MREC in the colons. So in this session we have studied about the LCDs, its importance, and then LCD signals, interfacing diagram, and also we have written a assembly language program to interface LCD to 8051 microcontroller. Thank you all.